Okay, we are now moving into our unit on energy and forces. Okay, so our essential question for today is, what is energy and how is it classified? So this actually has two learning targets, 11 and 12. Describe how energy can be transformed or cycled through a system. Be able to use a real-life example of how PE, potential energy, and kinetic energy are different and how the theory of conservation of matter works. Okay, energy is the ability to do work. Work is the application of a force through a distance. Energy is the ability to cause changes. It is not matter. It does not have mass or volume. But energy does affect matter. So energy will cause changes in matter. And a force, how force and energy work together, a force is what enables some work to be done, and energy is how you're able to do work. So those two kind of tie together. So there's two main types of energy, kinetic energy and potential energy. So kinetic energy is any type of energy that is in motion. Okay, now matter, all matter has kinetic energy because all matter is in motion. Okay, and we'll learn about this a little bit more about how matter is in motion in chemistry. If you increase the mass or the speed of matter, then that means its kinetic energy has also gone up. So that's one real big important thing that we need to make sure that you might want to highlight. If the mass of matter or the speed of the matter increases, then that means there's more kinetic energy. So let's take a look at some examples. Before we get to the examples, I'm going to go over potential energy. Okay, potential energy is energy that is stored, and it's usually due to position. So potential energy is any type of energy that is not in motion. So it's the opposite of kinetic energy. The way that you have more potential energy is you can also increase the mass of matter, or you can increase the height. Okay, so what that means is, let's say you have an okay, let's take a look at this weight over here in this picture. Okay, if we drop that from a higher height, then that means that potential energy, when that weight is dropped, all that stored potential energy due to position will get converted into kinetic energy, the motion. So the higher this weight is dropped for, the more force it's going to have to push that big piece of wood in the ground. And so the higher you have an object, the more potential energy you have. The more potential energy you have, then that means that potential energy can get converted into kinetic energy and apply more force. So let's take a look at some examples on potential and kinetic energy. Okay, so if you take a look at this pendulum, okay, what it's showing you is KE and PE. Notice the higher the pendulum gets, the more potential energy it has. So look at it over here. The higher the pendulum gets, the more potential energy it has. The lower it goes, the less height, then that means the more kinetic energy the pendulum has. And that's when the pendulum is moving. When it's not moving, it has the highest potential energy, the lowest kinetic energy. So again, let's look up here. While the pendulum is getting higher, more potential energy, it's not moving, so it does not have any kinetic energy. As it starts to move, kinetic energy goes up, potential energy goes down until it gets all the way back to the height again. So kinetic energy is the highest when the pendulum reaches its lowest point, because that means it has the fastest speed. When you drop something, it is the fastest at the bottom. Think about when you roll something down the hill. When you roll a ball down the hill, it's the fastest when it gets right to the bottom. That's where it has the most kinetic energy, the least potential. Let's look at another example. Okay, so this one is an example of a roller coaster, and it's also showing you potential and kinetic energy. So when he's at the top, he has the most potential energy because he's at the highest point. When he's at the bottom, he has the most kinetic energy. That's where the cart is the fastest. So notice while you're watching as the cart goes through the loops, when it gets to the bottom, it has the most kinetic. When it gets to the top of the loops, it has the most potential. So let's watch that again. High potential starts to decrease, kinetic is increasing. Highest kinetic starts to go up, potential energy increases, starts to go down, kinetic energy increases. Starts to go up, potential, kinetic. Let's take a look at this one. This is a different one. High potential at the highest. Okay, maximum potential because that is the highest point of the roller coaster. Highest point of the roller coaster has the most potential energy. As the roller coaster goes down, potential energy decreases, kinetic energy goes up until kinetic energy is at the bottom, the lowest point. Then you're going to have the maximum kinetic energy because that's where the roller coaster is going the fastest. Okay, we still have a lot when we go up. There's more potential, less kinetic. When we start going down, less potential, more kinetic. More kinetic, less potential. Okay, notice point E and A is higher than point E, so that's why point A is potential energy at the max. Okay, point F is not as low as point B, so that's why kinetic energy is the fastest here, not as fast here. But you still have more kinetic energy than potential. So I'm going to reset it and do it again. Maximum potential, because that's where the roller coaster is at the highest point and it's not moving. As it starts to go down, watch, kinetic energy is going to go up because it's in motion. All that potential energy gets converted into kinetic energy. Then, as it finishes its first steepest hill, that's where the roller coaster is the fastest, so that's where it has the most kinetic energy. Okay, so that's the difference between kinetic and potential energy. Now, let's look at, you are going to want to put this data table in your notes. So these are examples. So potential energy, remember, is energy in matter that is not in motion. So water sitting behind a dam, due to its position, it's not moving right now, it's just sitting behind a dam, that's potential energy. When they open the dam and the water starts to fall, then you've converted that potential energy into kinetic energy. A car parked on a hill is not moving. When it starts to roll down the hill, that potential energy gets converted into kinetic. The higher the hill, the more potential energy that car will have. The faster it will go when it rolls down the hill, more kinetic energy it will have. A wound clock spring. You wind up a clock spring or wind up a toy, and it has a lot of potential energy. When you release the spring, the clock hand begins to move or a toy begins to move, potential energy converted into kinetic. Gasoline in a car or sugar in your food has stored chemical energy that's not moving. But when the gasoline gets converted into kinetic energy, then the car moves. Or the food that you eat that contains some sugar, glucose, your muscles start to move, so potential energy from the chemicals in your food gets converted into kinetic energy. So please make sure you get those examples down. Now, energy is either kinetic or potential, but then there's types of energy or forms of energy. Okay, and if you'll notice, I'll give you a list of which forms are kinetic and which ones are potential at the end. Real easy way to remember all the different types of energy is Mrs. Chen. MRSCHEN, they each stand for a form of energy. Mechanical energy is energy in motion, so that's obviously going to be kinetic. That's the M. Okay? Radiant means light energy. And because light energy moves, it's also kinetic. Okay, so energy from our sun is radiant energy. That's what the R stands for. Sound, there's a picture to it, is also energy. Sound moves, so it is kinetic. It is a type of kinetic. So for the first three, these are all types of kinetic energy. Chemical energy, that's where the Qin comes into play. Chemical energy is energy that is stored in your food. Okay, glucose is stored in there, gets converted into ATP, which gives you energy, kinetic energy for your body. So chemical energy is actually stored, so that's potential energy. Then you've got heat energy. Heat or thermal energy moves, so heat is kinetic energy. Electrical energy is the flow of electrons around a circuit. So because electrical energy moves, it's the flow of electrons, it is considered kinetic energy. And then the last type of energy is nuclear. Nuclear energy is energy that's stored inside particles of matter, which are called atoms. That is stored energy, so that's potential. Okay, so let's take a look. Okay, there are two types of potential energy from those forms, Mrs. Chen, chemical and nuclear. Okay, so those are the two types of potential energy. So chemical is energy due to the arrangements of small particles or atoms, like the chemicals in a flashlight battery. And yes, you're going to want to write this down. Nuclear is energy that's stored in an atom's nucleus. We haven't talked about what an atom's nucleus is. We will do that when we get into our chemistry unit. Okay, this is atomic energy. And then most of your forms of energy are kinetic. Okay, so heat is the movement of those atoms or particles. Examples, warmth surrounding a car's engine. Sound is the movement of small particles, sound from your headphones. Radiant, photons are little particles of light that move, that's your sunlight. Mechanical is motion of large pieces of matter, like the movement of a car's wheels. So those are all examples of kinetic energy. Okay, so before we move on, we're going to talk about how these forms of energy can be converted from one to another. So chemical energy can be converted into types of kinetic energy. Chemical can be converted into mechanical energy. Nuclear energy can be converted into heat. And then if you look, you can also do kinetic to kinetic. Okay? Heat can be converted into radiant energy. Mechanical movement of the car wheels can also be converted into sound. So all these types of energy can be converted to each other. So we're going to look at some examples for that. Okay, before we start looking at energy transformations, I want to go over this theory of conservation of energy. This theory states, and it's very similar to the theory of conservation of matter, which we mentioned briefly in the previous unit. Energy cannot be energy can be converted, meaning changed. So another word for converted is changed. Okay, but energy cannot be destroyed. Okay, it can be transformed or changed, but not created. Okay, so energy can be changed or transformed, but not created or destroyed. So you can't create or destroy energy. All you can do is the energy that we have, you can change it from potential to kinetic, from kinetic back to potential, from kinetic to kinetic. Okay, so let's look at this. In many energy conversions or energy transformations, this is where energy is being changed from one form to the next. More energy is wasted than used for work. For example, automobile engines typically waste more than 2/3 of their total energy used, primarily through heat. That's why when a car has been running and you feel the hood of the car, it's hot. That's because some of that gasoline potential energy that got converted into mechanical energy, kinetic energy, some of it also got transferred as heat. On the other hand, electrical motors convert electrical energy into mechanical energy with only about 10% of the energy wasted via heat. Energy efficiency means converting energy from one form to another with the least possible waste. Law of nature is called the law of conservation of energy. So, we can never convert 100% of our potential energy into kinetic energy. For example, if we look at this roller coaster, so here's the total amount of potential energy that this car has right now. Well, it's going to get converted into kinetic when it goes down the hill. Not all of this potential energy will get converted 100% into kinetic. So take a look. If you notice, there's still some potential energy over here. So not all of that potential energy got converted in kinetic. What that means is some of that potential energy got converted into the mechanical motion of the wheels, but due to the force of friction, which is a force that goes against motion, when the wheels move against the tracks, some of that potential energy is converted into heat energy. So that's why that's never 100% efficient when you convert energy. You will never have that. But what you do try to get is the most efficient way. So talking about automobiles that run on like gasoline, they are not as efficient as electrical cars. Okay, they don't convert most of the energy into the mechanical energy. The cars powered by gasoline convert more to heat. So let's take a look of how energy can be transformed. Let's take a look at the simple flashlight battery. Chemical energy in a battery, remember chemical energy is potential energy, is converted or changed into electrical energy, then finally into light energy and a small amount of heat energy. So all that chemical energy that was stored in the battery, 100% of it does not get turned into light energy. Some of it gets turned into heat energy. So it's not 100% efficient. Okay? But that's an example of how energy can be converted. Chemical energy, which is potential, is converted into electrical energy, which is kinetic, and then turned into light energy, which is also kinetic, and then a small amount of heat energy, which is also kinetic. If you look at a home furnace, chemical energy stored in natural gas, a fossil fuel, is converted into heat energy. So that's how a home furnace works if it's run off of fossil fuel. Okay, so now we're going to take a look at some other examples. Go here.
Transformation of energy. According to the law of conservation of energy, energy can be transformed from one form to another. The process by which one type of energy is converted to another form of energy is called transformation of energy. For example, in petrol and diesel engines, heat energy is converted into mechanical energy. In a generator, mechanical energy is converted to electrical energy. In an electric fan, electrical energy is converted into mechanical energy. Energy, an activity. Shown here are a few devices that work due to transformation of energy. Classify them according to the transformation. Observe the highlighted image and click on the appropriate transformation.
Okay, so if we have speakers that are plugged in, okay, speakers, when they're plugged into an outlet, contain electrical energy, which is kinetic. That kinetic energy from electricity gets converted into sound energy, which is also kinetic. So this one, we have kinetic being transferred into kinetic. Electrical energy from the electrical outlet being converted into sound through the speakers. A light bulb, okay? A light bulb is going to give off light and a little bit of heat. Inside that light bulb, you have whoops, wrong one, hit the wrong one. My bad, where's the right one? I missed it, here it is. No, whoops, sorry. Okay, so that light bulb is, again, plugged into an outlet, so it contains electrical energy. That electrical energy gets converted into heat and light. Okay, a generator, okay, contains, so a generator contains chemical energy that gets converted into electrical energy. Okay, let's do the battery. Well, okay, we'll do burning of magnesium. Burning of magnesium. Magnesium is a chemical energy. You can see it's producing light and heat. A battery contains chemical energy. Okay, and depending on what the battery is doing, it's probably gonna convert it into electrical energy. Okay, a television is plugged in, so it has electrical energy, and you're gonna have electrical turned into light and sound. A nuclear reactor contains chemical energy that's usually transferred into some form. Whoops, wrong one. Oh, I think we've done enough examples. You're going to do more examples on your practice on your left hand, practicing how energy can be transferred. So a couple more examples. In order to get food to grow, we take energy from the sun, which is light energy, which is kinetic. It gets converted into chemical energy. So you go kinetic back to potential. Electrical, if you heat up a stove through electrical energy is kinetic, gets converted into thermal energy, which is also kinetic. When you eat food, maybe ice cream is not the most healthiest choice, but maybe a fruit would have been better in this picture. It contains chemical energy that gets converted into mechanical, because if you don't, that's why if you get hungry and you don't eat enough, you can't go about doing your daily business. Gasoline contains chemical energy that gets converted into mechanical energy, so potential to kinetic. And then the last example of types of energy transformations, potential energy, the ball's on the top of the hill, it's not moving, it's at a high height, so it has a lot of potential energy. When you push the ball and it rolls down, that potential energy gets converted into kinetic. Now notice, this wouldn't happen without that force. This guy applied a force to the ball to get that energy transformations to happen. Okay, so after listening to the notes, you should be able to give some examples of how energy can be transformed. Okay, so the example of a fan, electrical energy being transformed into mechanical energy and sound energy. You should also be able to give a real-life example of how potential and kinetic energy are different. So the last example we just did, ball on top of a hill has potential energy. When the ball is rolling down the hill, that has kinetic energy. And you should be able to explain how the theory of conservation of, energy works. So that's when we're talking about how energy, we can't create it or destroy it. All we're doing is changing it from kinetic to potential, potential to kinetic, kinetic to kinetic. Okay? So that's with all those energy transformations. We're not creating or destroying energy. We're just changing it from one form to the next.